Solving quadratic equations using the formula. The quadratic formula will calculate the solutions of any quadratic equations. So far, we have done quadratic equations where we have solved by factoring, and sometimes quadratic equations can't be solved by factoring. So if we have that problem where we have something like x squared minus 6x minus 1, we can't solve that using factoring because there are no factors of 1 that when you subtract them will give you 6. However, we can solve this equation using the quadratic equation. And the quadratic equation is always this form of the quadratic equation, which we write as ax squared plus bx plus c. And you've seen this several times now when we were factoring that we use this form where if a is 1, it's easier to factor. A is some other number, it's a little bit harder to factor. Now we're going to look at actually solving this quadratic equation. And I'm going to go through basically the proof of this quadratic equation for you to show you how this is done. And so if you have ax squared plus bx plus c equals 0, then we can solve this equation to get x by itself. And so I'm going to basically use all of the stuff you have learned this year in order to do this. So the first thing is that I want all the x's alone on one side. So I'm going to get rid of the c by subtracting c from both sides. And so ax squared plus bx equals negative c now. And then I don't want ax squared because what I'm going to eventually do is completing the square, so I want to get rid of that a. So I'm going to take and I'm going to divide a off of everything. And so my new next step is x squared plus b over a x equals negative c over a. And now I'm actually going to complete the square. And if you remember completing the square is taking b over a here, which is this, taking half of that, so I'm going to put the 1/2 like this, and then squaring that. And I'm going to add that to both sides. So okay, so I've completed the square here so that I can make this simply x plus b over 2a squared. Now I'm going to clean up the other side a little bit, so I'm going to do this squaring here. So this is really b squared over 4a squared, if I square both of those parts, c over a. And I'm actually going to flip these around because I don't like that negative first. And I'm going to flip them around. I'm going to give them a common denominator. So a common denominator here would have to be multiplying everything by 4a over here. 4a over 4a, that's still multiplying by 1. If I multiply by 1 there, I don't have to change anything else in the equation. So then what I have is negative 4ac all over 4a squared plus b squared over 4a squared. And so now you notice I have a common denominator, and this is still equal to this x plus b over 2a squared. So I'm going to go on to the next step here and combine these together. So, and when I combine them together, I'm actually just going to take these two and flip-flop them around. So this is b squared minus 4ac all over 4a squared. Okay. Now, my next step, since I have this squared on this side here, is I'm going to take the square root of both sides. So I'm going to take the square root of this side, and I'm going to take the square root of this side. And so since I've taken the square root of both sides, this side on the left is x plus b over 2a. On the other side, I'm going to separate the square roots, top and bottom. So this is b squared minus 4ac all over, the square root of 4a squared is 2a. Okay, now my x is still not by itself, so I need to get x by itself, so I need to subtract b over 2a. And when I do that, you notice I have a common denominator again. And on this side now, I just have x because these cancel out. And on this side, I have all over that common denominator. And again, I'm going to put this negative b first. So it's negative b, and this is plus or minus b squared minus 4ac. That's all in the square root, all over 2a. So there's that quadratic equation formula that we were talking about. And just to go back up here, I forgot to put plus or minus square root when I did this. When it's equal to, it's got to, if it's not equal to 0, it must have the plus or minus on it. And so I need that positive or negative on that side. And so here is what x equals. It equals negative b plus or minus b squared minus 4ac all over 2a. So back to our lesson. That's where this formula down here that they have given you. Where did the formula go? Oh, shoot. Oh, here it is, down on the bottom. So here's it, negative b plus or minus the square root of b squared minus 4ac all over 2a. And now we're going to use that and apply it to some problems. So first of all, let's talk about what quadratic equations are and are not. Quadratic equations have to have an x squared, but they can't have anything greater than an x squared. So they can't be cubed, they can't be to the fourth power. They can have a middle term, or they can have no middle term. They can have, or must have, a c on them. Otherwise, c is 0, and this equation is really simple to solve. And so they also could be negative. So here's a negative one. So here, if you look at the ones that they cannot be, they can't be to the fourth power. They can't have more than 3 terms. So that one has more than 3 terms. If they have just 2 terms, they can't have anything that's bigger than a squared. So let's take a look at an example here that they have. It says a quadratic equation y equals x squared plus 2x plus 1. That's the same as saying 0 equals x squared plus 2x plus 1, which is the form we're looking at most often. Usually they do the y equals when they want you to graph it. So but that is the same format. So a is 1. There's the 1 right there. B is 2, and C is 1. And so they simply put these into the formula, and they solved this. So this is negative 2 plus or minus the square root of 4 minus 4 all over 2. Well, 4 minus 4 is 0, and the square root of 0 is 0, so that whole thing cancels out, and you just get negative 2 over 2, which equals negative 1. Now notice we only got one answer for this, and we know that all quadratic equations have 2 answers. Well, since this is perfect square, really x equals negative 1 and x equals negative 1, but we only do write one of them. So you can get a quadratic equation that just has one answer if the answers really are 2 of them and they're the same answer. Alright, so let's try some problems. So here is y equals x squared plus 2x minus 3. And again, let's label what a and b and c are. A is equal to 1. B is equal to 2. And C is equal to negative 3. So we're going to put that into our equation. Negative b plus or minus the square root of b squared minus 4 times a times c that's a negative 3 there, all over 2 times a. And then let's do this calculation. So this is negative 2 plus or minus 4 under the square root plus, because negative times negative is positive, so plus 12 all over 2. And then we have to continue with this, so we have negative 2 plus or minus the square root of 16 all over 2. And so this is negative 2 plus the square root of 4, the square root of 16, which is 4, all over 2. Or it could be negative 2 minus the square root of 16, which is 4, all over 2. So we actually get two answers when we do this. And 4 minus 2 is 2, and 2 over 2 equals 1. So x can equal 1. Or it can equal negative 2 and negative 4 is negative 6 divided by 2, which is negative 3. So our answers can be 1 or negative 3. And if you factored this one, you would find that same exact thing. So we can do this by factoring. So, a couple more of these. Here we have x squared minus 1. Well, if we have this a, b, and c, what's a? Well, again, a is 1, because there's a 1 there. B, there is no b term, so b is 0. And c is negative 1. We can still apply this to the formula then. So we go negative 0 plus or minus the square root of 0 squared minus 4 times a times c all over 2 times a. So we have 0 plus or minus, so this is gone. Here we have 0 squared minus 4 times 1 times negative 1. So that's 0 minus, plus or minus 0 minus 4. Actually plus 4, because positive or negative times negative is positive. So we have plus or minus the square root of 4 all over 2. And if we take the positive of that, that's positive 2 over 2. If we take the negative of that, that's negative 2 over 2. So we get 1 and we get negative 1. Which, if you know factoring difference of squares, this factors into x plus 1 and x minus 1. And so those are indeed our answers. Again, one last problem here. Again, it's always the same formula. So x equals, and then a is 1, b is 4, and c is negative 5. And so b, negative b, plus or minus, b is 4 here, plus or minus the square root of b squared minus 4 times a times c. All over 2a. So I'm just putting those numbers in. This is basic substitution that we're doing here. And then we're figuring this out. So this is negative 4 plus or minus 16 plus 20, because again these turn to positive, all over 2. So 16 plus 20 is 36, and the square root of 36 is 6. So negative 4 plus 6 all over 2, and negative 4 minus 6 all over 2. And when we do that, negative 4 and 6 is 2, so 2 over 2 is 1. Negative 4 and negative 6 is negative 10 over 2 is negative 5. And so x equals 1 and negative 5. Just a quick hint, this is not ending up negative inside this square root. If it does, then we have another issue, which is imaginary numbers, which we will get to next year in 2 years when you do Algebra 2. So just keep in mind that's always going to turn out positive for you right now, because we won't give you any problems where it would turn out negative. So here's your assignment. There are 8 problems to use a quadratic formula on.